If you don't know me, I'm Chris Kersey. I run this channel, Kersey Fabrications. I've been doing 3D printing for a long time. I am a software developer by day, though, and so I've been wanting to incorporate more and more of my software development and what I do kind of as my hobby side of that for a long time. So what I'm going to do here tonight is I've got a brand new board. I'm going to go through the documentation to set it up properly. This is supposed to be both educational as well as just walk you around through this if you haven't seen it before. This ties directly into the work that I've been doing on my Iron Man project, which I have codenamed OASIS, and that project is building the most just real-time and realistic version of what was originally an Iron Man helmet, and there's going to be more and more content on that coming. I've been doing a lot of coding on that for a little while now. I'm going to walk you through exactly what we're doing. We got some hardware hands-on stuff as well as some software stuff that I'm going to be doing on my Linux laptop. But I really, if this goes pretty quickly and everything works well, then I may actually get my OASIS software running on here too, just to show that all of the software and everything's installed. But that does have some dependencies that may make compiling and stuff take a little bit longer. Let's show you the product that I'm going to be installing, and then I'm going to take a step back from the product, and then we will just talk about Jetson and Linux, and we'll do all of that as I'm going through this. All right, so let's start out. I'm just going to jump into the board that we're going to be using here today. So let me go ahead and switch to the desk camera. This is by a company called ARK Electronics. This is an American company, and they primarily focus on drone components, but this is one of those cases where components for one industry can be ideal for another industry. And so again, this is meant for a drone. That is not going to be how, at least initially, I'm using it. I'm not saying I won't be putting this into a drone at some point, or maybe another one of these. But for right now, I needed something that had battery inputs for my Iron Man suit. And I've been powering the usual Jetson board off of just a big laptop battery. It's not ideal. I can't monitor the battery usage via software in any easy way. So I'm always looking down to see what my percentage is by looking at the side of the battery, which is kind of a pain. So I was looking for a component. Number one, it has to be a very small form factor because, again, I'm wearing it. Number two, battery power and battery power monitoring. I have to know what the battery level is. Again, so I reached out, ARK Electronics. I'm on LinkedIn. If you're on LinkedIn there, please feel free to reach out, and we'll link up there. But I've been following these guys, the ARK Electronics guys, on LinkedIn for quite some time. They make some amazing, very small form factor, high engineering quality products, again, here in the United States for the U.S. drone market. They sent this over to me. This is the packaging it came out, and they came out with a little magnet. They sent me this. This is a prototype one of their boards. It has a couple of known issues I'm not worried about for this demo and for me trying it out. But again, they were kind enough to send this over to me. No sponsorship or anything like that. They were nice enough to work with me on this one. So let me, I'm going to get my strap. I don't want to blow one of these boards up anytime soon. So I do have an electronic strap that will be grounding me. It's off to the side here. You won't see it. So let me show you what this looks like. And there it is. So that is the ARK Electronics board that we're going to be using. This is called Just a Jetson because, as you can see, there's Just a Jetson right here. But as you can see, this board is very small, has a number of very small form factor inputs and outputs. It does have CSI 1 and CSI 2 connectors for stereo cameras. As you can see, some of these, I won't go over all of this here on the board because I don't know them all off the top of my head yet. But we got some USB headers. We've got different GPIOs on here. This is a 5-volt input to power the board off of. This is the XT60 input. This is the one I'm primarily going to be using. as well as, I believe, if I'm not mistaken, I think this is an XT30 output. But either way, it's a battery output that you can use as well that will be powered off of this one. As you can see, a lot of the components are surface mount in a way, kind of like an embedded system more than a PC. And I'll show you the regular Jetson here in a minute. But what we've got here, we've got a couple of USB ports, and like I said, some of these ports around here are also USB, but these are the easy to access, you know, keyboard and mouse type ports. There's an HDMI port for video output. This is the USB-C port, which I believe is their flashing port. And then we have a regular RJ45 network interface port. I believe that's going to be, yes, that is gigabit Ethernet. So I didn't want to say that if I was wrong on that one. But there we go. That is the board. And as you can see, very compact. On the back here, we have a M.2 M key, a 2242. This is for your solid state drive. And then we have a M.2 key E 2230 port, and this one is for the Wi-Fi card. I'll be showing you those in a minute. But that is all for that board. And we've got a fan header here. This is the 4-pin fan header that is typical with the Jetson. And then this is the SIM slot, which will go straight into there. All right. That is the board we're going to be installing in just a moment. And as I was saying, this is a SSD. So this is a M.2 2242, which should match up as that 2242 that I have there on the back. And this is a 1 terabyte drive. And we will bust into that in a minute. Along with that, I wanted an easy way for me to power this on the desk. So I found these USB-C to XT60 connectors. I thought that would be convenient. I can power everything with USB-C. And I needed all these fancy, so these are, the connectors you saw on that board are all kind of, at least as far as I know, they're pretty specific to the drone industry. But luckily I was able to go on Amazon and buy a whole pack of connectors. So that is a pretty nice pre-crimped connectors that I can use when putting together this with my suit and my various components. Alright, so I think that's all I'm going to need. You notice I haven't mentioned a Wi-Fi, I haven't mentioned the Jetson yet. We're going to be talking about those here in just a minute. Alright, so what are we installing in there? This is one of my NVIDIA Jetsons, and this is the one we'll be transporting or transferring over to the new system. This is one I've already modified, so some of this stuff is not stock on here. So this is pretty much the standard form factor of an NVIDIA Jetson. This is an NVIDIA Jetson Orin Nano, 8 gigabyte. This is the one that you get in the development kit if you buy a development kit. Again, pretty standard. This is the module that we will be removing to put onto that other board. As you can see, I already have, this one already works. I actually tested this right before the stream to make sure that this one was up and running and everything was ready before I tried to install it onto that new board. This is the hard drive on this one, and this Wi-Fi adapter here will be the one that we're transplanting onto that other board. As you can see, this one's by another manufacturer, but this one, like I said, works fine, but it does not have the connectors, it doesn't have the battery power that I need, which is why I reached out to ARK for this particular project. And again, I've got these crazy long antennas here. This was to get the best Wi-Fi coverage out of this I could. Doesn't matter, the ones on the typical Jetson are much shorter than this. Alright, so let's go ahead. We're going to go ahead and get all this transferred. Actually, before I do that, let me show you the guide. So I think I want to do the Jetson input here. This is ARK's Just a Jetson page, as I was mentioning. They have the pinouts on here, the flashing guide, all of the connections, a block diagram of everything that's on this system. They even have a 3D model that you can, I believe, download. Yep. So look at this. So this is a 3D model in case you're doing development. There's a step model that you can use to build your own enclosure for this. I will be doing that when it comes time to install this into my helmet or my suit or wherever it's going, I will be downloading the step model and actually doing this using a Fusion 360. It's a fantastic piece for a manufacturer to provide, particularly since they're providing it on a GitHub repo like this, rather than having to go through some sort of lengthy process to actually get them to release it to you. They have a block diagram of all of the components. So this is obviously where your Jetson Orin is going to plug in. Gigabit HDMI. They have, this looks like all the electrical side, voltage regulators, diodes, all that good stuff, overcurrent protection. That is all in there. And as I mentioned, they also have a pinout diagram. So this is all what I was telling you just a minute ago. They have the UARTs that are output. So if you just need UART to attach to an external input. The CSI connectors, again, they have a CAN bus on here, which if you're into automotive and all sorts of things are adding CAN buses these days. I know 3D printers are adding them. I'm assuming this means that drones have them also these days. We've got, again, USB headers, and again, battery output, battery input. There's a 5-volt input specialty header that I was showing you a minute ago. And then we have the fan header, as well as the force recovery, which on this one, so typically when you go to install on your Jetson, you have to short some of these pins out in order to get it to boot into recovery mode. It's kind of a pain. You have to find a jumper, you have to get a screwdriver, and hopefully you don't short anything else out. But I noticed when I was looking at their block diagram, their recovery is actually going to a button, which makes life a lot easier when it's time to reflash these things. All right, so back to this. So that's the Jetson, and there's a, there's a reverse side as well. All of the various signals, everything you need to wire this up, they've provided for you. Again, like I said, I really like it because it's provided without any, NDAs or anything to get all the information. It's really nice. And then there's the flashing guide, which is what we're going to be doing here today. Notice, you can get it pre-installed if you buy it as a kit, and everything will be ready to go. Or, as with mine, it's just a board. So I'm going to come in here and click on their GitHub repo. Actually, let me do that a little bit different. Let me click on this one. All right. And then this is the carrier setup. It contains instructions and scripts for flashing it. Clone the repo, host PC, yada yada. This is my host PC again. This is a Linux based laptop. I will need a Linux machine to do this, I believe. Don't know all the other options. You could be running Windows with some sort of virtual machine, or potentially a container or something. Tells me all of this: setup, script, download. We're going to run setup. Once the setup script is finished, you can build the kernel. We're going to add the Wi-Fi network. Then we're going to go through the flashing. Once it's done, we should be able to SSH into it. That'll tell us whether it's working or not. And then there's they have an ARK software package called ARK OS, which I am not familiar with, but let's see, Pi 6X. My guess is this is going to be a drone-centric, ARK OS collection of software services and tools for drones. Okay, so we will probably not be going through that part in this video today, since, again, my initial target is not droning. Anyway, let's go ahead, do the hardware installation side of things. Then we will move on to the software side. All right, so for the hardware side, again, this is our board. The first thing we need to do with this is actually disassemble. So let's take apart this one with all the pieces we need. And then we will be ready to install it onto the new system. Let's put it here nice where everybody can see what we're doing. I'm going to let's pull the fan header off of the board. And then there are 2 screws holding this on. Looks like the camera's struggling a little bit, but it's not too bad. Alright, so pull that off. We're going to need to reuse all of these screws because my board did not come with screws of its own. And we're going to pull these little tabs on the side and that will pop the module out. Alright, so that is the Jetson module. Alright, normally the Nano line has this SD card slot. We're going to try not to use the SD card slot because we want to run directly off of that SSD instead. But this is the back of it. You can see this is the mounting mechanism for the heatsink. Heatsink is just a single fan. Pretty standard. Alright, let's flip this over. Again, we're not going to use this SSD. Hey Chris, why are we not using this SSD? Well, we're not using this SSD because it's too long. It will not fit that other board. That other board's a little bit more compact, and so it does not have enough room for this SSD. But we are going to use, man, I put that one on there pretty good. But we are going to use the Wi-Fi adapter. Get this off of here, again saving these screws if I don't lose them. Hopefully everything's the right size screw. And just pull that straight out, I believe. There we go. So that'll work. Again, I kind of wish I didn't have these long Wi-Fi connectors on here, but it's fine. That should be all we need off of here. Now this one can go back into the box. We'll save it for next time. Let's grab the board. Let's start with the back side. Let's put these new things on the back. I do need to open up my SSD card. Grab some scissors. 5-year warranty on this, and I did try to pick one with a pretty good data rate on this. So hopefully it gives me pretty good performance. Okay, there's a terabyte in the palm of my hand. And this one's going to go on the 2242 side. Let's go ahead and see if this is the same size. I don't know if it is. If it's not, I'm going to have to go find something because, yeah, that does not fit. This is not the right size screw. Let me see what I can find real quick. Alright, I am back. Sorry about that. But I think I brought enough screws to figure out the job. Brought a number of options here. I've got 2.5s and I've got 2s. Let's see if that fits this. So this is an M.2 WiFi. Let's see if this one holds it down. It is the right size, but I don't think it's going to hold down this card. I don't think it, yeah, it just misses it. The head's not big enough. So luckily, I have some washers. So we're going to rig this thing up until it works. So I'm going to take one of these M.2 washers. It is the right size washer. It should ground this properly, which is the main thing I'm worried about. But it is an M.2 screw. You'd need some slightly larger heads though, but that looks fine. Nothing is going to short out from that at all. So let me grab another set of those because I need one for the Wi-Fi card. Alright, so let's do the Wi-Fi card. Should just work. I'll slide that one in here. Yep, that just works. And we're going to use the same, just put that right on top of it, but nonetheless, we're going to grab that washer, and we're going to do the same. We're just going to drop it. That's what we're going to do. We're going to drop the daggum screw and lose it now that I've gone to all that trouble to find one. Alright. Let's see if I can get this in here without dropping it. Apparently I should have grabbed a magnetic screwdriver. Would have been a whole lot more useful, particularly with as small as this is. Put this over here so you can see what I'm doing. And we're just going to tighten that down. Again, be very careful. Don't over tighten this. These PCBs don't need it. They don't want it. So there we go. Did mention earlier, this one actually does have a PCIe connector. I assume that this will work with a lot of those new PCIe peripherals that are available for like the Raspberry Pi. but I don't want to speak for the company. I haven't tried any of them, obviously, but that is a nice PCIe header on there for some daughter boards or something. If nothing else, you can get like a PCIe expander possibly. I don't know. Okay, we're going to switch over to this. This will slot in here. Alright, we just slot it in and then lay it down. And that is it. We make sure our clips are good. And then we are going to hope that these are the right size screws. And then they go exactly the same place the last ones went. Yep, those do still fit. Although, I'm starting to question if they're too long. Are they too long? The stock ones are too long. Are these M.2.5s? Or are we dealing with M3s? What are we dealing with? Because I got the M.2.5s over here if I need them. But I do think that these are too long. We're bottoming out. Yep, we're bottoming out. Alright. I mean, you don't technically have to have these. I'd want to put them in there before I did anything rough with this, obviously. But looks like I could use some M.2.5s. Let me see what I've got. Let me see if these are 2.5s. They definitely look bigger than the other ones. So let's just grab it a 2.5 by 4. Let's try a 2.5 by 4. Let's see if that does that fit in there. It does. Okay. So these are in 2.5s, and the 2.5 by 4s that I have seem to be working just fine. And then once we get the board all in, I'm going to make sure that I get this header turned right and plug in the fan header. Alright. Yay, okay. So the fan header goes right there. And I think this board, from a hardware perspective, is done. That is it for the hardware. Again, these are my Wi-Fi antenna. Power for the board is going to come in here. I'm going to hook up to my host machine with this one in a few minutes. Let's do it. Okay, so hardware-wise, we're all done. There's not much that I can check here. I could power it on, see if LEDs and such come on. That might be worth the time, but at this point, I think I'm just going to switch over to software and get going on the software side, because there may be, you know, several things I have to do from a hardware perspective, a software perspective, to get this going. Again, working on my Linux workstation here for this one. So we're going to switch over to this one right here. Again, using the GitHub ARK Just a Jetson repo. This one's just all their Jetson kernels, apparently. Alright, the first thing we need to do is actually pull down this Git repo, because we need all of these scripts and everything on here to get going. So, bring up a terminal. Directory, ARK, Jetson. Let's try that. And I'm going to rename it, because I didn't like the way I spelled that. Oh, I still can't spell it. Wow, this is what you get for typing on a stream. Let's be more careful. Alright, there we go. Now we'll CD into there. I'm going to pull down this code. We're going to grab that clipboard link. And we're going to git clone. And I don't know how much this environment is set up and ready for all of this at this point, because I haven't done a lot on this install. This is a fairly new laptop for me, so I haven't gotten it all set up at this point. So if I'm missing any tools or anything, and we have to pull those from Linux, you'll see that live as well. Again, Git's not even found, so we're gonna need to install some tools. Clearly, I have not gotten this laptop set up completely, so we're gonna git apt install. I think if we do, I want the build essentials. Yeah, let's start with that. I think that's going to cover most of the things. Hopefully my hands are not anywhere where people can see when I'm typing. That's good. Okay, that's already been installed. I don't know how Git was missing. Alright, so let's pull that down. Yes, we want to pull down all the Git packages. Alright, that git clone should work now. Alright, easy peasy. Alright, so let's go into that directory. Now we basically start through the process and we're going to follow along. Alright, run the setup script to download and build the Jetpack. Alright, we're going to try that first. We're going to see if their setup and everything works. We're going to set up. Hopefully this pulls down pretty quick. If anything gets too big, I will hardwire it because right now I'm on wireless. But my wireless in my house should be pretty good to pull this down. I'm pulling 10 megs a second. That's not too bad. So this is, you can see it's pulling down the root file system for Tegra. Tegra being the Jetson platform. There you go. It's going to untar everything. This may take some time. Shouldn't take too long. It's a pretty spiffy laptop. There we go. Just finished. Now it's pulling more stuff down, doing some more installation for us, doing a lot of unpacking. This is great. Looks like some hardy shell scripting here to make this easier on us. Doing all of these installs. We got some Jetson installs, some bootloader, we got CUDA. So it's building the complete file system for our Jetson here. It's putting a bunch of configuration stuff on there for us. Looks like we're pulling down some public sources. Most likely the kernel sources. Alright, we're extracting the bootlin toolchain. We're basically installing a bunch of sources right now so that we can build the framework for this from scratch, which is what we're doing here. So what's great about this, clearly a lot of this is open source, starting with the NVIDIA Jetson sources. And then what they've done in this is just provide all of the tools, the shell scripting, everything you need to make sure you can build it specifically for this hardware platform so that you get up and running. It's a manual way of doing it, but I think they suspect that most people that are going to be buying a board of this kind of building a custom solution, know what they're doing, even maybe even appreciate the fact that they've provided a bunch of shell scripts in case they need to modify something and want to replicate what they're doing. So I think this is a good move on ARK's part. Just as it says now we can build the kernel. That only took 9 minutes and 21 seconds according to their script, which is pretty cool. So let's go ahead and grab that. And do that. All right. This is two different platforms. PAB, I think, is a different Jetson board that they have. I'm assuming JAJ is just a Jetson. And so if that's the case, let's go ahead and choose 2. And it is now building our kernel for us. It went ahead and pulled down the configuration files that was already part of this repo, most likely. I noticed that there was some stuff for, let me go back up here to the top. There's a device tree, for example, that's already in here. Yeah, there's view all the files, and now we can see there's some more shell scripts that they're doing. Anyway, I'm hearing my laptop spin up. We're definitely compiling. So we're going to compile that kernel for scratch for the just a Jetson. And then once we're done with that, it looks like we can just add that kernel, or excuse me, add our Wi-Fi information, which I will go ahead and do, but I'll have to go away for a second while I do that so you guys don't know all my secrets. Alright, so the kernel's done building now. Now it's doing all of the installation. So these are all the files that it built during this install process. Now it's installing it to the local tree. Alright, so it says it's got R2Cam, CSI2's already pre-built, yada yada. Everything's ready to go, built for JAJ, which like I said, I assumed was just a Jetson. Now, it says that we can go ahead and flash, but I do want to add my Wi-Fi information. So let me go ahead, I'm going to switch off of this. We're going to switch to the wide camera real quick while I just run that shell script it told me to add my Wi-Fi information to it. Alright, it says we can flash. So we want to connect micro USB to the port adjacent to the mini HDMI. Okay. We're going to power on with the force recovery button held. You can verify, and then we're going to verify that it actually came up. Alright, let me show you how we do this. Alright, we're going to switch back to the desk camera. Luckily, I have done this before on other boards. A couple of things we need to be prepared for. Let me grab one of these adapters. I didn't want to have to power this by battery while sitting on the desk, so I found these on Amazon. These are just little XT60 to USB-C adapters, and it should power it enough. I've got a high power USB-C adapter off camera, so that should power it. We need to go USB-C to my host computer. So that's that laptop I've been showing you guys. So I've got a high quality USB cable. I actually bought this from Adafruit. It's high quality USB-C cable. That is going to plug into this port here, right there. And then we're going to take and plug this into my host computer. All right. That should not power the board. All right. That is just for data. Now we need to power the board. So I have this, which I've already tested on another adapter earlier to see if it provided enough power. It should. That's all I got for you is it should. If it doesn't, I'll go get a freaking battery. I've got batteries in the garage. I can do that. All right, so this should power it up. But while I'm powering it up, I need to hold this recovery mode button, which is right here. You see that? All right, let me show you. See that recovery mode button? I'm going to hold that down while plugging it in. And it should show up on the host machine while I do that. So I'm going to hold it down. I don't know if I should show you the host machine or what. Let's just show you the board first. I'm going to hold that down. Should have put feet on this so that it would be a little bit more stable. But I'm going to hold that down. I'm going to plug it in. I'm going to hold it down. Looks like it's going to power up. Hopefully that should be long enough. I will let go of the recovery button. I'm going to switch over to the Jetson. Alright, so let's see if LSUSB is showing this device. They're saying I should be showing NVIDIA Corp APX. Looky there. It's exactly what I'm seeing. It even has the same information, 955, 7523. So I'm really happy that part worked because that's one of the most difficult parts. But since they added that button to the board instead of me having to use jumpers or something else, that made it a lot easier. So, you know, that was kind of a big hurdle. It's powered correctly. It's running off that USB-C connector I've got. I think I've got like 120 watts on that USB-C connector, so there should be plenty of power. I'm going to copy that flash. That should just run. Now the moment of truth, we see if it flashes the board. It's not dead yet, so it's a good sign. Not exactly sure how long this will take us, so we will just give it a moment for it to do its job. And like I was telling you earlier, normally you can do this on like an SD card that's actually on the module. But we obviously don't want to do that. We need high speed. We need high performance. We're going to run off of the solid state drive that's on that PCIe bus on the back of the board. We're populating the root file system. Looking good so far. I really hope that this just goes super. So far, this has been going great. By the way, I really do hope that this keeps going really smooth. If it keeps going really nice like this. Then I should have plenty of time to show you the latest in my heads-up display, some of the cool new features I'm really excited about. But this, again, my goal is to have this board be the board in my suit. That's why I contacted ARK. They did not contact me. I said, hey ARK, I saw your Just a Jetson board. It's awesome. It's small. It runs off of battery. This is perfect for a wearable Jetson. And so that's what I'm using it for, as a wearable computer. This is looking great. I'm going to give major props to ARK if this works just like they said it was. If they've really built all this logic into their scripts, I'm going to give them major props. It just it just cut off, so I think we're rebooting. We're rebooting. Let me show you what I'm seeing on the desktop. On the desktop, I'm seeing the fan has stopped and this red light over here in this corner is on. So I am seeing things here on the desktop. We're looking good. And notice it is flashing to NVMe, so that should mean that we are flashing actually to the SSD card. Well, I don't have an SD card on the back of the module, so it has to be flashing to the SSD card. It's the only option it has. Yeah, okay. So let me show you what it's done here. It's formatted the app partition, allocated everything, formatting app partition done. Yep. Now, if you'll notice this tar command, let me see, this is the system image. So what it's doing now, it is uncompressing the system image, all the root file system, that kind of thing. It is uncompressing all of that to the new file system that it just created. So now it's a matter of time for it to actually uncompress everything that we downloaded earlier, that we built that root file system. I believe, if I'm not mistaken from what I've seen before, we're probably looking at a mix of scripting that ARK Electronics has done that goes around the typical Jetson scripting from NVIDIA. And so they've adapted it just to make sure you get everything installed correctly for the new main board that they've done. When you make a new piece of hardware, things are going to be slightly different. They may be on different addresses. You may have a couple of pieces of hardware on your board that maybe the stock one doesn't have, or maybe you've left something off because you didn't need it for your application. So that's why we built this kernel from scratch, was so that everything was designed for this board. It's got the right drivers, it's got the right addresses, it's got that right mapping so that everything is configured correctly. All right, look at there. It might be doing a reboot. I'm not sure. Okay, it's got one thing I like when it does this. You'll notice it actually did a complete log. It said it saved the log so that we can actually, if something went wrong, if we try to boot this and it doesn't work correctly, we actually have a log of what went wrong during the process and hopefully can fix that. But it does look like everything succeeded. So the first thing it tells us to do next is just to try to SSH into it to see if, can we get into it? Let's find out. Look at there, straight into it, even using a DNS entry. And I think it said the password Jetson. Look at there. Whole installation process. I mean, it's a little too soon to celebrate because I haven't installed anything on it. I haven't done anything with it. But for a first step, getting the entire system installed, making sure that the install actually works by logging into it. So we do have a running system at this point on this Jetson, but that's pretty incredible. Big props to them for an installation process that went extremely smoothly. I mean, that was really, really nice. All right, so I guess what I want to do next, I don't care much about working on the console for my use case. My use case is graphical. So I think what I'm going to do next is we're going to actually switch from using the laptop to seeing if we can get the HDMI output working and seeing if the USB works fine on the board so that all our peripherals are detected. So let's give that a shot next. I'm going to just scoot my laptop over a little bit. I can leave the SSH logged in, that doesn't matter. We're going to switch over to the desk. I'm going to show you what I'm going to do here. I'm going to unplug the HDMI from my laptop, which you have been watching this whole time. And we're going to plug that directly into the board. Carefully, I don't want to short anything out or break anything. And then we need my USB. Where's the USB? There's the USB. Alright, so this is a USB hub that's plugged into my keyboard, my mouse, everything. We're going to plug that into one of these. Alright. Let's see. Okay, does my mouse work? Hey, my mouse works. Alright, so now I can switch over and try to show you that. There we go. Okay. Let's see. It looks like this little screen didn't exactly come up correctly. We're just gonna move it out of the way. We're gonna pick a display, but other than that, it looks like everything is working just fine. That's fantastic. All right, okay. I'm kind of excited, trying to think of what to do next, but this is going really well so far. I think for the sake of, well, this looks like it's working so far, I'm going to actually shut the lid on my laptop. We're going to also unplug the host USB cable. It's not doing anything anymore. So that purple USB cable you saw me plug in shouldn't be needed at this point. I am going to just try to, basically what I'm trying to do is just clear up some room to work so that we can see how to get all of this set up. Okay, so this is working really well. You're seeing what I'm seeing. So this is the same desktop that I'm running on right now. I can open a terminal. If I need to, I might use the laptop again or maybe my other desktop just to make this a little easier because I am going to need to cut and paste some stuff at some point. But this is looking really good. Okay, so we are going to want to build some things on here and run some tests on it. Like I said, I was going to try to run my heads-up display on it so that you guys actually got a really good feel for what I have been working on, what some of this new software looks like, and also a good feel for how the Jetson runs. So let's get started. First thing I want to do, we are going to need a bunch of software installed. So let me go ahead and do a sudo apt install. I'm going to do that build essentials package. Not only that, but I'm going to also do git, again, default password on their installations for Jetson. No trade secrets at this point. That should be a lot of good stuff. Alright, let's let that go. I don't know if Chromium is going to be on here by default. It's funny that Thunderbird Mail isn't, but I don't see Chromium. Yeah, I'm not seeing it, so we may have to install that. Otherwise, I don't have a browser to like look things up and do what I want to install here. So we're going to do sudo apt install. Is it just Chromium? It is just Chromium. I didn't know if it was like Google Chromium or something. Chromium browser. Let's see if that does it. Basically, I just need to be able to browse to the repos that I need to download because I don't know them off the top of my head. So that's what we're doing here. There it goes. I don't know what it's doing sometimes, but here we go. Now we've got Chromium. That'll help make our life a little bit easier. Let's go ahead. That's just what's trending on Google. All right, so let's go back. I want to go back to the ARK. Let's go back. Yeah, let's go back to the ARK repo real quick. I want to make sure that there was nothing else I wanted to do there. Documentation. Oh yeah, one thing I haven't covered. Let's do that while we're here. How much is this board? The board, I think this is the board alone. I think the board alone is $680. I think that's, again, they're showing it here with a module. I think the board though alone is $680. And again, please keep in mind that it's a very specialized board built for specialized equipment like drones and like what I'm using it for, wearable. So if you're looking for it, it's just a Jetson. You can find it. You know what? I'll just paste this here. Again, no kickback for me on this. They just set me up. I can't post that. I'm on a different computer. Wow, that'll mess you up. I can't post it though. I just have to bring it up elsewhere. No kickbacks or anything on on this for me. They were just helping me out by sending me a pre-production sample, which is what this is. So I'm going to return the favor and send people over to them if they're interested in it. If you're wondering why the screen has got this yellowish color, I have seen all of my Jetsons do this when they go through the this video converter I'm using. I don't know why this is. This is a high-end video converter. I don't know why it would be causing this yellowish color, but I'm sitting here like on my desktop and it's not yellow. It's white on the screen. So it's just how that interprets this. So my apologies if it, but I guess it's a muted color. That should be easy on the eyes. All right, so that's just the Jetson, and let's go back over to the documentation. I did want to follow through with something that I was doing there. Again, there's the flashing guide, which should take us over to the GitHub. Again, I know I'm going through this kind of fast, but I did this earlier. There's the flashing. If we want to, we could install the ARK OS. We're not going to do that. Again, I'm not using this as a drone right now. We don't need to flash the bootloader because this one's already booting just fine, or it appears to be. We can change the clock speeds, which we can do later. We can install the super mode, which is the high speed mode on these Jetsons. So I can take that. Let me bring up another terminal. If I do that, it should go into high speed mode. Yep. You'll see that up here in the upper right, it says max speed super. So it's like, you know, full speed ahead. Now let's go ahead and look at, I want to install my software on it. I want to see if I can get that compiling. So let's go ahead. We'll go to OASIS project.net, which is where you can find my project. Did I spell it right? I think I did. There's the OASIS project. And here's the GitHub link if you just want to go straight to the source. And the only one I'm going to install for this video is Mirage. Mirage is the heads up. Dawn is the AI assistant. Spark is for like the hands and the repulsors and other parts of the armor. Let's get Mirage installed. Let's go ahead. I'm just going to pull this down just like any of you would. We're gonna go ahead here. We're gonna I'm gonna kind of make my usual directory structure that I like. Make directory code. You know, and then from code we can just, I'll do this. I'll go make directory, the OASIS project, the OASIS project, git clone. We're going to clone that repo, Mirage. Oh, this code base is getting a lot bigger. To Mirage. I bet you, let me go ahead and at some point I said, here's all the things you have to install. Now that I've pulled that down, let's see, do I have the README here that tells what I need to install this? Yep. So there's already some instructions here about the things that you should have to install. Let's go ahead and make sure that we're running the latest. So we're going to pull that down first. Pull that down first. And I still missed something, but I can type in E. So that's 2 commands, not 1. So let's go ahead and do the update. Gotta fix my documentation there a little bit. Do I want to worry about a sudo apt upgrade? I'm not sure. This may be too much for this stream. Ooh. There's only 268 things to upgrade. But some of it's GStreamer, and GStreamer is an essential part of my installation. So, boy, you know what? I'm going to say no for now. We'll do that in a minute if I need to. I don't want to break everything, so we're going to go with this instead. If some of this needs those upgrades, it will pull them in anyway. So let's just go ahead and do that. These are all the different components that we will need to install. Okay, the following packages will be upgraded. So there was a small subset of those that we need to upgrade. And then there's a whole bunch of other things, like the CUDA stuff. So let's pull this down. Alright, so that's done now. That should be everything I need. Now we should be able to do this. And then there are some other STL libraries I need. I think I included those here. I need SDL2 image and SDL2 TTF. Hopefully this is just replacing this TTF here. Let's see if that does it. See if it knows where all of those are. It does seem to know what they all are. So let's say yes. And then maybe this will go well. Notice I'm installing all the dev packages because I'm going to be compiling my heads-up display stuff, the Mirage package from scratch. Alright, make dir build. I'm gonna cd build. We're gonna cmake dot. Alright, we're missing something. SDL2 graphics. Need to update my documentation. -gfx -dev. Let's see if that gets the last package I need. So when I run CMake, I can go back up here and show you real quick. When I run CMake, what it's going to go do is going to go make sure it's going to find my platform. It's going to figure out where I am. It's also going to sit here and make sure that all of the packages that I need to compile this are installed correctly on the system. So that is done. Let's try CMake again. All right, found something else it can't find. It needs OpenGL. That's a lot of packages. No, okay, those are other packages. Let's see if that's what we need. Did that install everything we need, or is it still going to look for it? Oh, that looks like it was it. Seems to have found what it needed. Let's find out. So if I type make, it should just make, and we should be ready to go. If there is something that is still missing, it will complain and it will error, and I will go fix it. Package has gotten pretty big. Alright, good to go. Now the moment of truth. Will it run? One thing I know I need to do is it needs some of the symlinks created to the configuration and other things that are in the previous directory. So we're going to do that. We're going to do sounds. And we are going to do config. I think those are the only three I need. And notice it created those symlinks. Here, I'll show you. Created links to those directories, one directory down. Alright, so if I type Mirage and type Mirage-H, it will tell me all the options. Okay. And what we're going to do is Mirage, we want to do, this is going to be the USB cameras. I'm hoping that the default devices just work. And I don't have, no, that's not USB cameras, that's C USB for USB cameras. And then I do have 2 cameras, so I can tell it I have 2. Let's see if that just works. And if there are any errors or anything, then we'll go from there. Well, there we go. It's way too big because I'm obviously streaming at 1080p. So watch this. Full screen it. Well, damn. That just worked. Look at that, guys. That is so freaking cool. Frame rate up in the upper right-hand corner up there. You can see it's like 150 frames per second running on this. It's really, really working well. And the 2 cameras aren't synced, obviously, and they're upside down. But you'll notice these are independent cameras. And we're running, is that 190 frames per second, actually? Wow. I mean, it's just really killing it. There's a HUD. There's a HUD running. USB cameras and everything. Well, hell, that's absolutely wonderful. That's what we wanted to do tonight, right? So, new board, new installation, fully running HUD on this new board. That worked really, really well. And the performance is peak. Yeah, that's 190 frames per second right now. 190 frames per second we're running. And like I said, I mean, you can see how smooth it is. Like, that's awesome. These are those new global 90 frames per second cameras I was telling you about. Like, these things are sweet. These are the ones I might be putting in the next version of my helmet. The only thing they don't have is, like, night vision, which was a feature I was trying to do, but what you gonna do? Let's show you something really cool. You want to show you something really cool? Yeah, I think we can show you. All right, so let me drop out of that first. It can't download the mini map, which is why you're seeing all those curl errors. So that's those curl errors. I didn't install my map key to get the Google Maps, so you're going to see those errors. It's not a big deal. Let me show you the new piece of hardware. Let me show you the new board, because this will make it even cooler. So if I switch over to the desk camera, this is what I was telling you about earlier. This is a new piece of hardware. I designed the board itself. All the other pieces are from SparkFun and from Adafruit. Let's plug this into it. It'll show you what it looks like. We're going to USB-C into here. And then this just needs to go into that USB hub. It does look like I'm running out of USB hub. Actually, this can go straight into the board. Let me make sure I get it in the right way and I don't short anything out. Alright. Now this is going to power on. There's going to be a video out on this board soon, the whole thing. So, OASIS Aura. And there's the motion sensor. You can see real time. Alright, and I can actually rotate through these screens. Sorry for the... So there's the GPS. I'm not going to do GPS quickly. I'm inside, and GPS doesn't work, but there's the GPS display. There's environmental, like it has air quality. This takes a minute to heat up. Don't pay any attention to the air quality at this point because it takes a minute for this sensor to calibrate. But there's environmental sensing, tells me the temp, tells me the humidity, tells me the CO2 because I'm going to be wearing this in my helmet, and then tells me the air quality. ESP, now that's something coming in a little bit. We're not ready for that yet. And then again, the motion sensor. So, I'll turn this over because this is the way it will be in the helmet. The display will be facing the bottom. The sensors all face the inside of the helmet. All right, so let's start this up now that this is connected. All right, start it up, but this time I'm going to add the -U to tell it that there is a USB sensor attached. All right, let's do that. All right, so now you will see, did it come up? Did it work? Let me see something. It is not connecting to the USB, so I need to find out why it's not. You know what, I probably don't have proper permissions to access it. So if I look at TTY ACM, which is what it's plugged in as, you need dial out permissions. I'm probably not in the dial out group. I am not in the dial out group, so I'm going to do a system admin no just to demonstrate how this works. I'm going to change sudo change mod 666 on dev TTY, and again I should have just changed my user, yada yada yada. That'll take a little bit more time. I'm not going to do all that right now, so I'm just going to do that. And now when I run it again, I'm also going to pass it a -F, which should put me in full screen mode to start off with. Now it should be able to talk to the board. All right, now you see, it's hard to see some of these sensors. Now you see we have a proper temperature and a proper humidity right there, right up there. Proper temp, proper humidity. Okay, that is what it is in this room right now. Okay, you can see my CPU usage, memory usage, fan usage, all that good stuff. You'll notice my little guy over here, my Iron Man, his helmet is now green, showing me that the helmet sensor array is being detected properly. If I were to unplug it and it were to go away, his head would turn red. let's show you something. Okay, so this is one of the biggest features I've been working on for a while. This one took a lot of work. Not only that, but I have some new cool things because of this. I have multiple HUDs now. We can now switch between HUDs and show different screens. So I can tell it, I could be talking to my AI assistant, and I could say switch to the next HUD, and it would switch to the next one. Or I could do something cool and say switch to the environmental HUD. And we have multiple HUDs now, guys. This shows the environmental sensors for my suit real time. So the CO2 level, if it was able to calculate it at the moment, there'd be a heat index, there's a dew point, humidity, all this is showing up real time from this new sensor array that I have. Really excited about this. This took a lot of time because I had to draw the graphics myself and come up with what this new screen layout was going to look like. As you can see, all the cool stuff still works. I can show this. As I tilt it, you'll see that it tilts real time. It's actually a pretty cool display, right? Real time, right? Real time. All right, so if I switch, all right, this one I just finished. This is brand new. Switch to the armor display. Shows a full-size view of the armor. And if I don't have them here. They're in the garage, I believe. If I did have them here, as I turn on different parts of the armor, as I turn on shoulders and forearms and whatever, they turn on green and you start to see their settings. You see their temperature and you see their battery usage. And so every piece of the suit is independently powered. Every piece of the suit has independent thermal sensors, and so I have complete situational awareness of the suit that I'm wearing. And again, I can just switch between these. You'll notice these cool transitions. It's got slide transitions, it's got zoom transitions, it's got fade transitions, all built into the software, all custom software. So, I'm pretty proud of this. This has been a real exciting thing to work on. And I'll show you this real time as well. This is the full HUD. As you can see, as I tilt it, it finds north. As I look up and down, it finds the tilt angle. This one's super smooth. This is a brand new sensor that I'm using on this board that's designed for AR and VR. And the responsiveness is just killer. I'm really excited about using this one. The way that I've wired this up, the sensor, the inertial measurement unit, is actually hooked up over an interface called SPI. It's a very fast, very responsive interface. And I'm using interrupt handling so that the second that there's a change in that data, I receive it on that little microprocessor and it immediately gets sent. So the responsiveness is pretty much instantaneous at this point. So you can see, seems to like it, right? Seems to like it. Right, so let's just show you one more time. Again, all the sensors, again, the heat index is working out. It's figured out all the thermals and everything. That's Celsius up here, though, by the way. Keep that in mind. That's not Fahrenheit. I have the ability to change that. Like, you can set, like, I want these Celsius, I want these Fahrenheit, yada, yada, yada. And then, like I said, the armor display. So, that is cool that works so well. I have some new software, like I said, I've already written. Let's switch back over to the desk cam. I've written some cool new software to do the monitoring of the battery. That will go into the HUD to show me the battery voltage and the current that it's pulling. Like I said, I would even like to add an algorithm that actually estimates how much longer the battery is going to last based upon what kind of battery it is, based upon, how much juice it's pulling. Anyway, so here's the new board. Compact, worked out of the box. The installation was pretty flawless. It was completely flawless. I had zero problems with their install instructions. Their setup scripts worked great. The installation, the compiling of their custom kernel, all of that worked. Obviously, I have not tested every feature on this board. Haven't tested that sensor on that battery input. I haven't tried the Ethernet port. Like, there's a lot on this board that I have not had a chance to use yet. But I do want to thank ARK again for sending this over. The experience has been fantastic. It's been easy. You just watched it real time. It works really, really well. And switching right back over, it just worked. I hit the wrong key. Too many keyboards. Again, if you have any questions, please feel free to drop a comment on this video. This has been a lot of fun this evening. So happy that this went so well. Got the software up and running. It's been a lot of fun. Thanks for your time this evening, guys. It is only been just a little over 2 hours, which worked really well. So thanks again. Appreciate everyone joining me. If you enjoyed this, like I said, please leave a like on this video. And I will do some more of these. Maybe I'll just do some real-time coding. Maybe I'll show you some more of the features that I have in mind.